Hello everyone, today I'm going to talk about another rule in derivative, which is the quotient rule. This rule is used for fraction form function. The fraction form functions, as you know, contains numerator and denominators. Actually, two separate functions similar to fx and gx as we have in here. Based on this rule, first we have to take the derivative of fx, which is going to be f prime of x, and basically the top function or numerator in here, and multiply it with gx, which is denominator or the bottom function here, minus g prime of x. So we need to take the derivative of the bottom part and multiply it with the fx as it is. So we keep fx as it is, and over gx, the bottom function, in power of 2. Let's make it easier now. I'm going to define derivative as d, and what I'm saying here, basically we need to take the derivative of the top part. So I'm defining denominator as top function, so derivative of the top function times the bottom function as it is, minus, this time we have to take the derivative of the bottom function, so d bottom means the derivative of the bottom function times the top function as it is. So we keep the top function or numerator or fx in here as it is, over the bottom function in power of 2. Now let's look at the first example that we have in here. In the first example that we have in here, it's basically x cubed plus 5x squared plus 2 over cos x plus sin x, and easily we can apply the quotient rule. So the top part in here is fx, and the bottom part for us is gx. So what we have to do is to take the derivative of the top part first. So it's going to be du over dx equals, so the top part, let's take the derivative of the top part first. So it's going to be 3x squared plus 10x, and we know that the derivative of the constant number 2 is going to be 0 times the bottom part as it is, cos x plus sin x, and then we need to take the derivative of the bottom part, which is going to be minus sin x, and we know that the derivative of the sin x is cos x plus cos x times the top function or fx, which is x cubed plus 5x squared plus 2 over the bottom function, which is cos x plus sin x, and as the rule says, we have to use the power of 2 for that. So it's going to be cos x plus sin x in power of 2. As you can see in here, we easily applied the quotient rule, and first we took the derivative of the top part and multiplied with the bottom part as it is, and then we took the derivative of the bottom part and multiplied with the top part as it is, and then over the bottom function in power of 2. So now it's time to look at the other example, and I'm going to look at a more complicated example in here. Basically, this example is going to be the combination of the chain rule and the quotient rule. So in here, what we have e to the power of cos x squared, and this is going to be fx for us, and then we have the natural log of or ln of x squared plus sin x as gx. So what we have to do for this problem, again using the chain rule, for each of the part that we have for the top and the bottom part, and then actually combine it with the quotient rule in order to take the derivative of the whole function. So let's look at the quotient rule and then look at each term and use the chain rule in order to take the derivative of the whole function. So we have du over dx, and based on the quotient rule we need to take the derivative of the top part. So this is going to be e cos x squared, and for us, as you know, when we are talking about the chain rule, we have inside and outside function, and for here we have to use that inside and outside function. So this is going to be minus 2x and then sine x squared times e cos x squared times the bottom function as it is. So we keep the bottom function as it is. So it's going to be ln x squared plus sine x. And for the other term, now we have to look at the bottom term basically based on the quotient rule. So what we have to do is going to be negative or minus, and for the bottom part we will have again the chain rule looking at inside and outside function. So we need to take the derivative of outside function, keep the inside as it is, and then take the derivative of inside function. So using that rule we will have 1 over x squared plus sine x, and then it's going to be multiplied with the derivative of inside function 2x plus cos x, and we have to keep the top function as it is and multiply it with the derivative of the bottom part. So now this whole function is going to be multiplied with e to the power of cos x squared, and this whole function, the big function, the blue and green part, is going to be divided with the bottom function in power of 2. So ln x squared plus sine x to the power of 2. So as you can see, with the combination of the chain rule and quotient rule, we can easily take the derivative of several complicated functions. And here we took the derivative of a function which was basically a fraction form function, and we applied the quotient rule, and in the middle of the quotient rule we applied the chain rule.